This project is about like making emergency staircase like this in case of fire or other emergency evacuations. So what are we going to do is like we are going to apply the pull force of 1000 Newton and then weight of the persons, so which is like a tentative around 230 kg as per uh, which is like a minimum requirement as per EN 131. So this is provided by the customers, and then let us try to do that in SAP. File, and then new model, and then after that let us just make it from the blank project, and then let us add the dimension of the emergency staircase. Right click and then edit grid data, modify our source system, and then we let us just add something naming as A and B. So here our length is like 400 millimeter and the depth is like 160 millimeter. So let us make it 400 millimeter and then 160 here, and then there is nothing in Z, so E is equal to 0, and then okay. So after that we have to go to define, and let us first define the materials. So we are using like S355 materials and it's already done, but we can go to add new material, and from here we can just define our materials. So okay, and then define section properties, frame section, and then since it's steel, so we just have to click on the steel, and then rectangular, we are using the solid rectangular thing, so rectangular, and then section name 25 by 25 because our section size is 25 by 25 millimeter. 25 25 from here just choose S355. Okay, okay, and then let us try to draw here by clicking on this icon, and then let us just draw our beam thing like this. Escape. So now our model is drawn, and after that let us just select these two joints, go to assign joint restrain, and then these two joints are gonna be fixed, so just select the fixed, apply, okay. So our emergency staircase is done, and then we have fixed the joint. We have fixed the joint. Now let us go to define load pattern. So dead load is 1, and we are going to apply pull force. Pull force is dead, and self-weight multiplier is 0. Pull force and weight. with a person, add new load pattern. We don't have to analyze for snow load or any other things. Yeah, so okay, and then after that we have to go to define uh, load combinations. So we are just gonna add default design combos made as per the Eurocode steel frame design. Okay, so we have these two load combinations. Okay, so we have like defined the material and we have given the load combinations. So now let us just go to the assign section and then joint load force. So pull force, it's gonna be on negative y direction. So I'm going to give minus 1000 Newton, and we are gonna give this in this joint. So let us select this one and then apply. So we can see 1000 Newton of pull force has been applied. And again select the joint uh, and then weight of the person, and then let us give the force minus 230 kg. So 230 kg, it's gonna be around 2.25 kilonewton. So 2250 Newton and minus apply. So our these two forces has been applied at this joint. So why are we applying this at this joint is like to be more specific, we can distribute the force like pull force like 500 500 and then 2250 like 1225 1225, but we are trying to be more specific, so like a more factor of safety. So if this joint is able to handle this amount of force, then every joint will be able to handle this force. So I am just trying to be more specific. Mm, yeah, okay. And then after that design steel frame design, view revise preference. So from here uh, design code, I am going to use Eurocode country, and then if you want to change any of these things, then you can change, otherwise you can just okay, yeah. And then design steel frame design. So after that we can just run the model, and the model we don't have to run it, so just do, and then here like do not run, now run. Just save it as a somewhere before running. So we have not any warning message that is being generated, so it's fine. So if we try to start the animations, then we can see the effect of the force and the deflection in the shape because of our pull force and horizontal force. Then after that we can go to design, steel frame design, and then start design and check of the structure. So as we can see, we can eliminate this one. So as we can see, most of our member is under 0.5 and it is safe to execute our work. And also what we can do is like we can go to design, steel frame design, uh, display design info. So if you want to see the PMM interaction ratio, just click there, and then we can see the PMM interaction ratio of all the individual component. So we can confirm that our this member is fine and it works. So if we need to create a report, then we can just go to file and then create report. So once we click on the report, it will just make the report. So here we can see our report has been made, and from here we can just delete the unnecessary thing and use the things that we are gonna use in our one report. So we can do it like this. For now it doesn't matter. So, and that report it include everything, so we don't have to worry about that. Okay, yeah. And then after that, let us do some manual calculation also, which I have already done here, because manual calculation is also important. Yeah, so force, it's gonna be 2250, and I have tried to multiply it by some factors. And then length, it's 160 millimeter, like length from here to here, because we are applying force here and the moment is gonna transfer to this part. So moment is force into distance here. So force into distance, we got the moment value this. And then I is like a second moment of inertia. So we can get this by pi by 4 into radius into y. So pi by 4 into b8 into 4 is radius into y. So this is the formula. This is like a universal formula. We can get it from the code itself. So after applying this formula, we get the value of a second moment of inertia, and then we just calculate the stress. Stress is like a moment divided by second moment of inertia all multiplied by y. So after that, so y is just radius divided by 2, because y is like, suppose if this is uh, this has the radius of 8 millimeter in case, then we have to use this one. So after that we can calculate the stress, and after using the stress we can calculate the pull force. So here also we have applied, so 1000 Newton is our pull force, and then if we multiply it by 1.35, this is just for the factor, and then we can get the area pi r square, and then pull stress is gonna be force by area. So we got the pull stress of like this, and then our total stress is gonna be this stress plus pull stress. So total stress is 611.058. And then also, like, we need to calculate the pull out force from the masonry. So the pull out force from the masonry has a formula like pi d into H effective into FPD. So H effective is like how much deep we have to drill in the masonry wall in order to get the in order to it will not like pull out from the wall. So on applying the formula, we can get the value of 4 4 4.52 kilonewton. And since our applied force is like 1 kilonewton plus 2.25 kilonewton, it's 3.25 kilonewton in total. Yeah. So this value is less than the pull force. So we can conclude like our model is safe for the analysis.